linked list, and this problem is basically saying we have been given a task to check whether two linked lists are identical or not. So two linked lists are identical when they have the same data and with the same arrangements too. If both linked are, they will return true. So if you see in the case of our case, 1, 2, 3, 4, 5, 6 and 99, 54 are not identical, since the datas are also different and the arrangements are also different. Okay, so the output is false. So it's a simple problem. I'm not going to waste a lot of time in explaining this particular problem. So it is going to be done in very easy manner. Okay, so what we can basically see is first what we have is we have a class solution. Okay, then we have public boolean. We are checking whether they are identical or not. So we are checking true or false. We have a head pointer and a head to pointer. Head pointer is nothing but pointing to the linked list of first linked list h1. Okay, so if I say this is h1 and this is as h2. Okay, if I say this is as h1 and this is h2, while both head 1 are not equals to null. So the first head cannot be null. Only then we are going to proceed. And also the data present cannot be null. And the data h1 h2 not equals to head2 dot data. Return false. So we have to check the data present in both the cases are match. So if it matches, then we are going to go with this pointer, head equals to head dot next, head 2 equals to head dot next. We are just iterating one after the another. We are iterating one after the another in the linked list. If both head 1 and head equals to null, means they have both list pointers should exhaust after insertions. Okay, so over here insertion is being done. So basically we are checking the head pointers. So we are returning false if the data doesn't matches. If the data matches, we are just going to traverse. Okay, we are going to check both the list pointers should exhaust after the insertion. So head 1 equals to null. So after insertion, there will be a certain time after that this head will become null, because there is no next element. Remember one thing, no next element is equals to null. Means suppose this is a linked list. This is the linked list. So this contains the address of this. This contains the address of this. Okay, similarly, and it goes on. So there will be a condition when it has reached the last element. Okay, for my example, it has reached the last element 66. It has reached the last element 55. So in this case, this is a false one. This will definitely not work. But suppose two linked lists have reached the last element and there is no element left, that means it has terminated. So I can say my head has become null, means there is no value. There is the head is pointing to no value, means there is no value left. That means we have completed the iteration. Similarly for head 2. So we are going to return true if either of the head pointer is not learned, meaning there are still elements of the list. That means in this case we are going to return the false. That was how simple this problem is. Boolean are identical, but in order to solve this problem in GFG, it is easy to solve because they have defined the node class. But I'm sure pretty much that after practicing some questions on linked list, you will be able to define your own node class. So we have to take a data which is storing as the data. So if you know a linked list contains a data, okay, a head, okay, and you can see a previous one if it is in case of a double linked list. Okay, so we have a data, we have a next equals to null. Next equals to null because we don't know the next element. Okay, so we will be pointing to the next element later on when we are traversing through it. Okay, so this was today's problem statement. I hope you could understand this problem statement. This passes all test cases. I can write test cases passed.